Hi, everyone. Thanks for joining us for this Hangouts today. I'm Philip Molter. I'm the co-CTO here at Frog GmbH. And today we're talking about a paper that really hit the internet pretty popularly yesterday. It's a research paper entitled A Glance Through the VPN Looking Glass, IPv6 Leakage, and DNS Hijacking in Commercial VPN Clients. And we have a number of people who join us on the Hangouts. Feel free to use the Q&A to ask us questions during it. You can also vote on those questions as they come up. We've had some questions already coming in through Twitter. I'm going to grab a couple of those right now. And I think the question that of course everybody's concerned about who's a Viper VPN customer is, what is Viper VPN doing to address the points raised in the study? So I think we'll start off by talking about what some of those points were, where Viper VPN was found to be at issue or to be vulnerable compared to other providers, and then what we're going to be doing to address that stuff. So I think the first point of the study was that in the majority of our applications, Viper VPN was not susceptible to the IPv6 leakage vulnerability that they published in the paper. And this vulnerability is basically saying that when you're running two different networks, which commonly happens when you're running an IPv6 network, when you're running two different networks, traffic over the one network, the IPv4 network, which is what most VPNs typically run over, is secured just fine. But this other network, because it doesn't fall under the auspices of that IPv4 network of that VPN, it's not secured at all. And so there are these side channel information leakages that can happen when that IPv6 network is active. And what the paper found was that in the majority of cases, particularly the Windows apps and in the Mac apps, Viper VPN's not vulnerable there. And that's because for performance and usability issues, we effectively turn off IPv6 networking when you're using those applications. In addition, the paper also said that everybody who uses an iOS app is also not vulnerable, because iOS under the hood does the same thing when you connect to a VPN. But what they did find was that everybody's Android apps are vulnerable, including Viper VPNs, and that's really a function of the way that the Android operating system works, the way that it manages its VPN connections. And so in that case, just like every other VPN provider that's operating on Android, Viper VPN's connections are vulnerable to that IPv6 leakage. Now, that doesn't mean that we can't find a solution for it. It just means that we're going to have to get really creative to do it. And so we're looking at that right now. We don't have a solution for it yet. Again, we rely on the underlying operating systems to do a lot. And in this case, Android isn't doing what we have capable in other operating systems. But I think we'll be able to find one. We've been looking at it, and it doesn't seem to be insurmountable. The other issue that the paper highlights is this idea of DNS leakage. And it hits different providers in different ways, to different degrees. Viper VPN was found to it was really, really hard to attack Viper VPN in this way because of the way that we run our infrastructure. But there is a very small attack vector where someone can get in and do this kind of behavior. The real key here is that what can happen is, after you make a connection or before you make a connection, a malicious network that you're operating on can send your computer a bit of networking configuration information via the DHCP protocol, which most networks use to configure dynamic devices. They can send you a malicious configuration that directs your computer to not send that DNS traffic over the VPN or over any other network, but to send it locally out, in which case it won't be secured by the VPN, it won't be encrypted by the VPN, and they'll be able to see that information. There's another question about some of these things that the paper is talking about, so I'll go into more detail about why that can really be bad. But suffice to say, it's really hard to do it on Viper VPN's network, because something just may have flapped. So if people saw something flap, I just saw something flap through my screen. But it's really hard to do on Viper VPN's networks because we host our own DNS infrastructure, and it's all hosted locally wherever you are connecting. So if you're connecting to us in Amsterdam, or you're connecting to us in Singapore, or you're connecting to us in Hong Kong, in each of those locations, we're running a DNS server to serve you in that location. It's hard for people on these malicious networks to attack us in that regard, because they're going to have to know, A, where you're connecting to before you connect, which means they're going to have to do a little precognition there. They can make some guesses based on prior behavior, but it's really hard for them to know where you're going to connect, so that they can know what DNS server to specifically direct your connectivity for. A lot of the providers that were found to be vulnerable to this are using third-party DNS providers like Google or Chupa or OpenDNS, and those are really easy to predict. They can put in the routes ahead of time, so that even after you connect to the VPN, you're still going to be sending your DNS traffic out through their network. So the attack vector is very small, but it is something that's present. And what we're going to be looking at is updating our DNS configurations, so that not only will the traffic be going to the local network there, but that we'll also be able to have it always have to go into our endpoint. This is something that our engineers are already working on. It doesn't look like it's going to be too difficult a job for us to reconfigure, and we'll be able to push that out. I think in the long term, what we're going to do is, because we control the applications on our side, we'll be able to make some changes within the applications themselves as well, so that if we start detecting things not moving the way that we expect them to move, that we'll be able to effectively shut that down. It's one of the benefits of being able to control our own, software, is that we can introduce those things. But the fix that we're putting in will work even for those people who working for those people who are even using manual connections. So I want to go in a little bit about the DNS leakage, because that was where Viper VPN was found to be particularly vulnerable, as opposed to the IPv6 leakage, where we were basically where we're capable of being safe. We are safe. The DNS leakage is actually really, it's quite ingenious that the paper was able to come to this. It's a side channel attack onto the network, really as everything is. They're not compromising the protocols themselves. They're not compromising the encryption. What they're basically doing is putting in configurations into machines that direct some traffic, so that it doesn't go through the VPN, so that it doesn't get encrypted. In this case, what they're doing is they are saying, if you're talking to a DNS server, normally that traffic's going to get routed out over the VPN connection. It's done through routing rules present on the device. Routing rules are implemented in terms of specificity. So I can put in a blanket rule that says send all traffic out this network, but I can also put in a more specific rule that says take this traffic and put it out over this network instead, and the more specific rules will win. In addition, there are rules, depending on the operating system, there are rules that can say, even if a rule is less specific, if it's got a higher weight on a network interface, that it should be directed out over that network interface. There's sort of these complicated rule sets. What the configuration is doing is saying, when you're on one of these malicious networks that will do this to your machine, it'll send you a configuration packet that basically puts in one of those most specific routes. At that point, and the route is specifically for the DNS server, or for a network that includes the DNS server but doesn't include your VPN server. When that happens, the more specific route takes effect. The DNS traffic starts going out through the through what we call the gateway to service it, and since it didn't go through the VPN, it didn't get encrypted. As I said previously, we're not particularly vulnerable to that, because it's really hard to put in a more specific network route for our DNS servers, because they're already very tightly grouped on the network. They're already in a very specific network band already. But it's not impossible, because it's not the tightest that it could possibly be. Likewise, oftentimes putting in these routes after the fact will break the VPN connection and take it down. So to make it really effective, you need to put it in ahead of time, and that gets back to knowing what server you're connecting to, since our VPN servers are going to be different based on what site you're connecting to. A lot of people were a little bit confused about that. Like I said, it is a side channel check. It doesn't take all your traffic and dump it out over the network. It only takes the traffic going to those specific networks, which they're targeting the DNS traffic because that exposes what sites you're talking to. The other particularly problematic part of that is that if they have control over your DNS responses, they can also send you to places that you don't think you're supposed to go. DNS is like a phone book. Give me a name, give me the phone number. If I give you a bad phone book, I can make you call somebody else, and if that person pretends to be the person you're supposed to be talking to, they can do things like feed you bad information, send you to places you're not supposed to go, or they can just hear, everything that you have to say and make decisions based off that. So this is a pretty significant attack that they can do. I think in most cases, the people that are doing this are going to be setting up very specific networks. This isn't something that you're typically going to find like operating on a coffee shop Wi-Fi or operating on a conference Wi-Fi, or a lot of places that people use Viper VPN. But it's conceivable that somebody could, for example, go to a conference, set up a wireless access point that has the same name as the access point in the conference, and then do that maliciously to, say, distribute malware or watch what everybody is doing. There was a question that came through about the vulnerabilities on Android. Is it the same as being on an open network? It depends on which one you're talking about. If you're talking about the IPv6 leakage, it's similar to being on an open network for IPv6 traffic. So if your device is being put on an IPv6 network and you are getting DNS answers that allow you to talk via IPv6, then yes, it can be like being on an open network, because that IPv6 traffic won't go through the VPN and it won't be encrypted. In terms of the DNS leakage, no, it's not the same as being on an open network. Most of your traffic is still going to go over the VPN. It's your DNS traffic that won't. But again, the vulnerability there is that since they control the phone book, since they control sort of converting you from a name to an actual location, they could actually send a very large chunk of your traffic out through, say, a caching server or something like that will allow them to see all of your traffic. So in certain configurations, it can be almost as bad as an open network. But again, it's a very, very hard attack vector to set up. The IPv6 is much more akin to an open network. If you have IPv6 traffic, then that IPv6 traffic is treated no differently than open network traffic anywhere else. There's a question: is restricting IPv6 traffic a long-term solution or just a short-term fix? Would going back to IPv4 mean repeated recycling of IPs? I think those are two different questions. Is restricting IPv6 traffic a long-term solution or just a short-term fix? No, it's a short-term fix. It's not a long-term solution just because more and more networks are moving to IPv6. I think in the VPN sphere, we can actually make that last quite a while, because we can service VPN connections and give them an IPv4 network and basically shut off the IPv6 network, which is fine. You're shutting off one network or another. But at some point in time, the internet's gonna be moved to a majority IPv6 network, and we're gonna want to service that as effectively as possible. We'll see that, we've seen that Apple has already announced in iOS 9 that all of their apps are going to have to be IPv6 capable apps. They say today about 70% of them are. So IPv6, where iOS is shutting down IPv6 for VPNs today, they may not do that in the future. We don't know yet whether or not they are going to do that. So that may be an issue going forward. iOS IPv6, we may end up seeing this leakage start to appear where it hasn't appeared so far because of changes that they're making underlying the system. And so restricting IPv6 is probably not the long-term solution. What's probably a better solution is, looking at the IPv6 routing tables, adjusting your applications to account for them, and to make sure that traffic isn't leaking off to the side into unknown networks. Note that IPv6 isn't the only alternative network that devices can be on. It's by far the most common, but there's a lot of other kinds of networks that things can be on, older networks, that I would have to assume have the same sort of issues. The world large today is IPv4 and IPv6, so that's what the study focused on, and I think that's where the major attack vector is going to be. But realize that anytime you have a device that bridges multiple kinds of networks, and you have a system like a VPN that focuses on only one of those networks, you open yourselves up to that kind of side channel attack. I see that there's a question about the study mentioning Tor as a countermeasure. This is something that the study brought on pretty aggressively near the end as a countermeasure mechanism, and I think they do a pretty decent job of talking about some of the pros and cons of a Tor network. In what situations does Tor work and does Tor not work? So Tor works really well if you are trying to quote unquote anonymize your traffic. I think the report does a very good job of explaining that VPNs offer privacy and security, but they don't anonymize traffic. This is something Golden Frog has said from the beginning. People have come up and said, you know, your service doesn't anonymize me, or can I be anonymous using your service? No, you can't. Tor does a much better job of that. There have been some papers studied about the de-anonymization of Tor traffic, so it's not perfect as it is. It's not perfect in any network, but that's where Tor's focus is. And the way Tor does that is they bounce you around a lot of hops to prevent any one hop from knowing much about the traffic. The downside to Tor in that respect is that Tor connections are not very performant at all. All that hopping comes at a network latency and a network throughput disadvantage, such that Tor connections tend to be very slow. It's one of the things that most people recognize when they first start using Tor is that sites load more slowly. They can't watch videos, or they can't watch videos at a very high bit stream. There was an earlier question about whether or not VPNs would support 4K ultra high def streaming, and there was a response from another person saying that because of the requirements, yes, it should be fine. I don't see a way that the way that Tor is currently distributed that you're going to be able to do things like 4K or even HD streaming over Tor. It's very difficult to do. I think the bigger problem with Tor is that Tor only works with applications that are designed to work with Tor's proxying mechanism. And that works a lot for web browsers, particularly the Tor bundle. But there's a lot of traffic on the internet that's not web traffic. And there's, particularly in the mobile device space, there's a lot of mobile device traffic that's not web traffic, or that's not configured to go through a proxy like Tor. So you can't secure all your traffic. You can only secure the specific traffic in the applications that are specifically designed to use with Tor. So Tor's not good in those kind of use cases. VPNs are much better because they secure at a lower level. If you're sending anything out through the network and you have your VPN properly configured, all of your network traffic, no matter what it is, whether it's coming from your web browser, whether it's coming from some esoteric application sitting on your desktop, whether it's coming from some random application that you downloaded from the App Store to run on your iOS or your Android device, all of that traffic gets encrypted, all that traffic gets protected and can't be seen by prying eyes, can't be inspected. Whether it's secure or insecure, the metadata is completely hidden, and it makes for a much more overall secure solution without requiring any sort of application changes at all. Realizing in security, there's not one protocol or one service that's going to fit everybody. People look for different things out of their VPN and their security providers, and where Viper VPN we're really targeting things is to make it really easy for people to secure things. That may mean some trade-offs in that things may not be as anonymous. It may mean that we have to pay more attention to side channel attacks, but we want to make it really easy for people to get on. Tor is not designed to be really easy for people to get on. It requires quite a bit of technical knowledge, and you know, and they really point that out in the paper well, what it takes to go through the process of getting Tor set up. We want our side to be easy. This is the easy solution that, you know, covers 95 to 99% of your security needs. And while we would like it to be the perfect solution, perfect is sort of the enemy of good here. And we want to provide a good to great experience for people that makes it really easy for them to feel secure on the internet. Another question that we saw come in is, what is the real world severity of these issues? And I'll talk about each issue independently. On the IPv6 leakage side, the networks that are running dual stack IPv4, IPv6 are getting to be very common, especially in Asia. China runs a very robust IPv6 network. European networks are rolling that out pretty aggressively. In the United States, Comcast is leading the way on the residential internet side, rolling out dual stack to its customer base. So you're seeing a lot more of the dual stack IPv4, IPv6 networks. And so that information leakage, where people may not realize that their information isn't encrypted, is that's becoming more and more common. So I think that's actually not, it doesn't meet their expectations, and they don't really have a way of knowing that one way or the other. So we consider that pretty severe. We actually turned off IPv6 in our applications because we didn't have a good way to prevent those IPv6 networks from messing up the VPN connection. By turning it off, we get the security benefits, but for us, it was really more about making sure that the application experience was good, and we were seeing problems when IPv6 networks were active. The DNS one, I think in terms of those providers that are using third-party DNS providers, it's pretty severe for them because of how easy it is to reroute traffic to those providers and to maliciously impact it. For us, it's less so. It requires a much more concerted effort on the part of the malicious actor to do it. I think if someone was really targeting someone that they knew was on Viper VPN and that they knew was going to be accessing some specific server, so a very targeted acquisition, it would be a severe problem. But for the majority of our customers, it's probably not going to be an issue. Like I said, it's hard to target, and it's hard to create the general case for targeting a broad range of individuals. That's not to downplay the effect of it, but from an attack vector standpoint, it would be a targeted attack. It wouldn't be more of a blanket attack, which is possible with those providers that are using third-party DNS systems. As for its actual impact, I think the impact of the DNS one is just as severe, maybe not more severe than the IPv6 one, because if you did have that targeted attack, or you did have someone who is trying to aggressively target third-party DNS, once they get control of DNS, they can start redirecting people to all sorts of locations transparently, and use that as a means to distribute malware, which then gives them even more control over the system, or to filter or restrict their access to content in ways that would be completely transparent to the user. So we want to get that one solved. It's like I said, it was a really interesting research paper in terms of how they got that stuff to work. One thing I would note on that is that they found that on some platforms, I believe Windows 8, and they think maybe lower versions as well as KitKat, that they weren't susceptible to some of these attacks. So you can read the paper for more details in terms of the specifics there. But even in terms of some of the issues that were affecting even Viper VPN, it only affected it in very limited scenarios. So I have time for maybe one more question. I don't see anything else in the Q&A queue. I'm going to check our Twitter feed real quick. There's a question, we talked about this a little earlier, but there was a question in terms of what kinds of problems can DNS hijacking cause, and we talked a little bit about the fact that DNS operates like a phone book. from our standpoint, there's a few things that you get access to when you have DNS information. One is you can tell people to go to other locations. We talked about the malware concern there, the ability to direct them through transparent proxy servers. But the other thing is that DNS provides quite a lot of information about what you're accessing, when you're accessing it, and the relationships between those accesses. A common case we like to bring up is that if you have access to DNS records, then you know that someone first went to their doctor, then went to look up information on cancer, and then went to go talk to their insurance provider. And if that information made it back to the insurance provider, for example, they might change their rates. That kind of side link information can be very can expose a lot of information about users just from their use case. Can be damaging to them in that regard. But for the most part, what we focus on from DNS hijacking is what China does from the Great Firewall, and it's used to great effect to filter and block and affect the way that people interact with the internet. And I think if you're on a coffee Wi-Fi, DNS hijacking is often used to prevent you from getting access to sites. It's to prevent you from watching video. It's really basic stuff like that we think of as annoyances, but it impacts our ability to use the open internet. So, it's something that we focused on a long time ago. It's why we started our own DNS infrastructure. It allows us to control that to a much greater extent to prevent that kind of activity from happening. In terms of our DNS infrastructure, we don't log or track any of that information. It's really just kind of a pain in the butt for us to do that in the first place, and it doesn't bring any value at all to our business. So we keep that information out, and at the same time protects our users' privacy. So at this point, looks like we're out of time. If you guys have any more questions or you have any more concerns about this stuff, feel free to go to our blog where we've got an article up about this. You can post comments in the blog, or you can reach out to us on Twitter, ask questions via @ViperVPN, and we'll do our best to answer them. When we have fixes released for the issues that were raised in the paper, not only will we be putting them out in the apps and have them in the apps change logs, but we'll almost certainly be publishing a blog post about it to make sure that people are aware that the apps are now secure. And hopefully the next time that the researchers go through this analysis again, they'll find that ViperVPN and hopefully all VPN providers are handling these situations much better. So thanks for your time today. And if you're a Golden Frog ViperVPN customer, thank you for your business.